This is the problem number 12, which is consider a matrix A. Here A is a 2 cross 2 matrix. Which of the following statements is correct? A has two real eigenvalues and is diagonalizable over R. Second is A has no real eigenvalues and is not diagonalizable over R. Third is A has two complex eigenvalues and is diagonalizable over C. Fourth is A has no complex eigenvalues and is not diagonalizable over C. You can pause the video for some time and try to solve the question. Now moving on to the solution. So we know that the eigenvalues are the root of characteristic equation. That is, and this is the characteristic equation for any matrix A, and lambda is the eigenvalues here. So after solving this determinant, we'll get lambda square plus 1 is equal to 0. And for solving for lambda, we get lambda is equal to plus or minus iota, which means hence A has two complex eigenvalues and no real eigenvalues. Okay. Now for diagonalization, we see since A is a 2 cross 2 matrix, if A has two linearly independent eigenvectors, then we say the matrix A is diagonalizable matrix. Okay. Here we saw that since A has two distinct eigenvalues, that is plus or minus iota, and each eigenvalue will give us one linearly independent eigenvector. Okay, and hence since A has two distinct eigenvalues, and hence what we'll get two linearly independent eigenvector. Why? Because there are two distinct eigenvalues A have. Okay, hence A has two linearly independent eigenvectors. Since A is a 2 cross 2 matrix and A has two linearly independent eigenvectors, it means A is diagonalizable over C. Okay, so the correct statements are: A has two real eigenvalues, this is wrong. A has no real eigenvalues and is not diagonalizable over R, this is correct. A has two complex eigenvalues and is diagonalizable over C, this is also correct. A has no complex eigenvalues and is not diagonalizable over C, this is wrong. Thank you.